Here we discuss the star formation triggers. So we have already learned that the stars are formed from the clouds of dust and gas. So, and those clouds clump together under the force of gravity to form the protostars. So, initially they are formed from the interstellar clouds and they clump together under the force of gravity to form the protostars. So, these are the initial stages of star formation. And the evolution of a protostar to a main sequence depends on the initial mass of the protostar, and the mass of this protostar determines where it will arrive on the main sequence. So those things are already known. So now we will ask a question: what causes a protostar to form? What are the causes of protostar formation? So there are three mechanisms that triggers the star formation. So they are having very dissimilar origins. So three mechanisms by which the star formation triggers are. So the first one is the spiral arms of a galaxy, and the second one is the expanding H2 regions, and the third one is the supernovae. So the spiral arms of the galaxy is already known to you. And the H2 region is the region of interstellar atomic hydrogen, which is ionized. And the third one is the supernovae, that is the final stage that corresponds to the stage of a star. So we will discuss this in details later in this module. Okay. So first of all, we discussed the first trigger, the spiral arms of a galaxy. The spiral arms of galaxies are important locations for star formation because the gas and dust clouds they accumulate, they temporarily pile up as they orbit around the center of the galaxies. So we have already seen the spiral arms. So they orbit around the center of the galaxies. So in this process, the gas and dust clouds accumulates there in the spiral arms of the galaxy. So in such a spiral arm, the molecular clouds are compressed. So as it passed through the region. So the molecular clouds in the spiral arm are compressed due to the orbiting of the spiral arms along the center of the galaxy, and therefore the gas and dust clouds accumulates there. Here in the molecular clouds densest region, the vigorous star formation can occur. So here the molecular clouds are compressed. At this region, the star formation happens. So stars form ചെയ്യുന്നത് ഈ compressed ആയിട്ടുള്ള ഈ സ്റ്റേറ്റിലാണ്. ഇവിടെ അത് ഏറ്റവും compressed ആയിട്ടുള്ള സ്റ്റേറ്റ് ആയതുകൊണ്ട് തന്നെ star formation occurs there. The next star formation trigger is the expanding H2 region. So we have already seen that H2 regions are the regions of atomic hydrogen, that is ionized, the stellar atomic hydrogen, that is in the ionized form. So the massive and bright stars like O and B type stars emit immense amount of radiation. So they are having high temperature, so they emit the high frequency region. So these stars usually emit the ultraviolet part of the electromagnetic spectrum. So we know that the UV has got a greater frequency than visible. So due to this radiation, the surrounding gas is ionized. So the hydrogen there is ionized, and an H2 region is formed within the large molecular cloud. So the radiation coming from this O and B type stars ionizes the interstellar hydrogen. This in turn forms the H2 region. And The strong stellar winds and the ultraviolet radiation that the O and B type stars possess can carve out a cavity within the molecular cloud into which the H2 region expands. So, ഈ stellar winds ഉം ഈ ultraviolet radiation പിന്നെ ionize ചെയ്യും. So, ഈ O and B type stars ഒരു cavity അതിനെ ചുറ്റുമുള്ള molecular cloudനകത്ത് ഒരു cavity form ചെയ്യുന്നു, into which this H2 region, ionized atomic hydrogen ഉള്ള region expand ചെയ്യുന്നു. Okay. The stellar wind is moving with such a high velocity that it is supersonic. അപ്പോൾ ഇവിടെയുള്ള corresponding stellar wind എന്ന് പറയുന്നത് supersonic ആയി. The stellar winds are the fast flowing streams of particles that are emitted from the star. അപ്പോൾ സ്റ്റാറിന് ഹൈ വെലോസിറ്റിയിൽ എമിറ്റ് ചെയ്യുന്ന ഈ പാർട്ടിക്കിളിന്റെ സ്ട്രീമിനാണ് നമ്മൾ ജനറലി stellar wind എന്ന് പറയുന്നത്. So the stellar wind is traveling at supersonic velocities. That means velocity faster than the velocity of sound in that particular region. So corresponding H2 region also expands supersonically. So ഈ particles flow, ഈ stellar wind വരുന്നതിനനുസരിച്ചാണ് ഇതിനകത്ത് ഒരു cavity, molecular cloudനകത്ത് ഒരു cavity ഉണ്ടാകുന്നത്. അവിടെയാണ് ഈ H2 region expand ചെയ്യുന്നത്. അപ്പൊ ഈ stellar wind supersonic velocity travel ചെയ്യുമ്പോൾ corresponding expansion H2 region expansion supersonic velocity യിലായിരിക്കും. So a shock wave associated with the supersonically expanding H2 region collides with the rest of the molecular cloud. Okay, but they'll expand if there is a shock wave associated with it, and this wave collides with the rest of the molecular cloud. So in that mechanism, it compresses the cloud and a further star formation occurs. So we already kandu molecular clouds compressed ആവുമ്പോഴാണ് star formation ഉണ്ടാവുന്നത്. അപ്പോൾ star formation അതിലും O, B and type stars ഉണ്ടാവാം. So this new O and B type stars result from this compression will induce further star formation. Initially ഉണ്ടായിരുന്ന O and B type stars disperse ചെയ്തിട്ടുണ്ടാവും. അപ്പോൾ ഈ പുതിയ O and B type stars ഈ പ്രോസസ് ഇങ്ങനെ കംപ്ലീറ്റ് ചെയ്യും. So at the same time, the precursor O and B type stars that originally started the procedure may have dispersed by this point. Initially, expanding H2 region കാരണമായ O and B stars disperse ചെയ്തിട്ടുണ്ടാവും. But the new O and B stars will continually induce the further star formation. This process continues. So they emit intense amount of radiation, and also the strong stellar wind causes a cavity inside the molecular cloud, so into which the H2 region expands. So there is a ionized atomic hydrogen region formed inside the molecular cloud. So this the corresponding shock wave compresses the molecular cloud and star formation is being triggered. Okay, and the example for such a mechanism by which the star formation is formed by the expanding H2 region as Orion Nebula. So here the trapezium stars, we have already seen that the trapezium stars are the brightest stars of the Orion Nebula. They are ionizing the surrounding material. They are forming the H2 region. And this Orion Nebula is at the edge of a giant molecular cloud having mass of the order of some 5 into 10 to the power 5 times the mass of the sun. And the third mechanism by which the star formation is being triggered is supernovae. So it's the final mechanism which induces the further star formation. So the supernova is the death of the star, and this results in a catastrophic explosion. Catastrophic means a terrible explosion. So this usually blow the stars into bits. So ഈ explosion കൊണ്ട് stars ഇങ്ങനെ bits ആയിട്ട് മാറും. So the outer layers of the stars are ejected into the space at incredible speed. So the outer layers of the star are ejected into the space at very high velocities of the order of several thousand kilometers per second. So the corresponding shock wave is an expanding shell of the material. So this is also moving with supersonic velocities. Expanding H2 region. Here also the corresponding shock wave is moving with supersonic velocities greater than the velocity of sound. And this will impact the material in the interstellar medium. So in that process, it will compress the interstellar medium as well as it heat the interstellar medium. But compressed down, we already kandu interstellar medium compressed down, but star formation trigger. So this will stimulate the further star formation. So we have covered the processes involved in the star formation, from vast clouds of dust and gas into glowing spheres of nuclear fusion. That means the birth of the star is discussed, but the complete processes and the birth of the star is still unknown. For example, the spiral arm that passes through the giant molecular cloud tend to produce giant O and B type stars, but the stars which are induced by the supernova shock. So, we have 3 mechanisms. Spiral lamps will produce O and B. But those stars induced by supernova shock are predominantly A, F, G and K type stars. This the theory behind it is not known. And also in our galaxy, there is a lot of dust associated with the star formation that shield the new born stars from the destructive effect of the ultraviolet radiation from other hot stars that are close by. UV radiation from the nearby stars will cause some destructive effect on star formation. അപ്പോൾ അതിനെ ഷീൽഡ് ചെയ്യുന്ന ഡസ്റ്റ് എന്ന നമ്മുടെ ഗാലക്സീസിലൊക്കെ ഉണ്ട്. അപ്പോൾ ഇങ്ങനെയുള്ള കുറേ കാര്യങ്ങൾ സ്റ്റിൽ അൺനോൺ ആണ്. ഓക്കെ, ആൻഡ് one thing is that most of the stars that we observe in the night sky are on the main sequence, but there are some exceptions. For example, Betelgeuse. Betelgeuse എന്ന് പറഞ്ഞാൽ തിരുവാതിരയാണ്, തിരുവാതിര നക്ഷത്രം. അത് മെയിൻ സീക്വൻസ് ലീവ് ചെയ്തിട്ടുണ്ട്. So Betelgeuse has left the main sequence and now it's a red giant star. The hydrogen burning at the center of its core has stopped. So now the helium burning by fusion continues in Betelgeuse. And also Sirius also evolved from the main sequence. Now it is a white dwarf star and no nuclear fusion occurring within the Sirius. But most of the stars are on the main sequence, and there is only very small change in the mass and luminosity. So as long as the star is on the main sequence, there is no change in mass and luminosity. But as the star ages, there will be changes in the way in which the energy is formed. So, and this will affect the size and the luminosity. So, as the star ages, it leaves the main sequence and it begins the next phase of its life. So, main sequence stars are നമ്മൾ കൂടുതലായിട്ട് സ്റ്റഡി ചെയ്യുന്നത്. അപ്പോൾ ഡീറ്റെയിൽ ആയിട്ട് ഈ സ്റ്റാർസിനെ കുറിച്ച് സ്റ്റഡി ചെയ്യുന്നതിന് മുന്നേ നമ്മൾ നമ്മുടെ നിയറസ്റ്റ് ആയിട്ടുള്ള സ്റ്റാർ സണ്ണിനെ കുറിച്ച് ഡീറ്റെയിൽ ആയിട്ട് പഠിക്കും. അപ്പോൾ അത് കിട്ടിക്കഴിഞ്ഞാൽ സണ്ണിന്റെ ബിഹേവിയർ കിട്ടിക്കഴിഞ്ഞാൽ നമുക്ക് ബാക്കി സ്റ്റാർസിന്റെ ബിഹേവിയർ അത് വെച്ചിട്ട് കമ്പയർ ചെയ്യാൻ പറ്റും. We will discuss how the energy is produced in the core of the sun and how this energy is transported to the surface, and then how this energy is transported into the earth. So then we can look at the other stars and compare and contrast what we know about the sun. Okay.